Lastly, we have the scratch algorithm for addition. Now, this algorithm isn't necessarily better for teaching, but it is kind of a nice way to add without letting your mind get bogged down with too many numbers. For example, we're adding 87, 65, 49. The scratch algorithm is going to have us only count up to 10 and then start over. It's much easier to count to 10 and then start over 1, 2, 3, 4. If you think about counting on your fingers, for example, you can only count up to 10, and then maybe once you've counted up to 10, you start putting down fingers to represent that you're counting to 10 again. That's kind of what the scratch algorithm is doing for us. The way it works is you start down the ones column. We're going to add the numbers going down. So we have 7 plus 5. So we're just going to focus on the 7 plus 5 first. That's equal to 12. Now, instead of calling it 12, what we're going to do is scratch the last number that we considered, which is the 5. That's going to represent the group of 10. And then beside that, I'm going to write 2 to say that I'm starting my count over at 2. So 7 plus 5 is 12. The slash represents the 10 from the 12. The 2 represents the units that we're going to continue counting from. Then I'm going to continue adding. So my next number is 9. 2 plus 9 would be 11. So I would scratch the 9 to represent 10 from 11. And then I would put a 1 next to it. Now technically this is the last number in our list, so I could have just put the 1 here. But notice using the scratch algorithm, I'm never going to carry while I'm adding in the ones column, because every time I'm able to regroup, I make a slash. When I go to count in the tens place, I need to first count how many slashes there are. We had 2 slashes, so I'm going to add 2 in the tens column, because each one of these slashes represents another group of 10. So this slash and this slash are where I'm getting the 2. Now, adding down the tens place, I have 2 plus 8, which is 10, so I slash the 8. And I'm going to keep track of my ones digits to the left over here. And then I continue counting. 0 plus 6 is still 6, no scratching needed. 6 plus 4 is 10, that would require a scratch. And then I could put a 0 here, or since it's the last number in my sum, I can put it directly under the tens column. Now I need to go back and count how many slashes I have. In the tens column, we had 2 slashes, which meant we regrouped twice, which would be like the same thing as putting a 2 in the hundreds column, or just putting a 2 down here to represent the hundreds. So our final answer would be 201. Now this is nice for computing kind of in your head. It's easier to add from 0 to 10 than it is to add from 0 to 21, for example. So let me show you alternatively how the standard algorithm would look. 7 plus 5 is 12, and then we need to add 12 to 9. If you have that fact memorized, then this is not a problem. But if you need to count on your fingers, you don't have enough fingers to add 12 plus 9. And if you want to pull out a calculator, well, of course you could, but wouldn't it have just been faster to use the scratch algorithm? So when we add 12 and 9, we get 21. We write the 1, carry the 2, and then we repeat this addition process in the tens column. 2 plus 8 is 10. 10 plus 6 is 16. And if you remember that 6 plus 4 is 10, then maybe you remember 16 plus 4 is 20, so you could copy that down. Now, the standard algorithm is not bad. I'm not trying to say that it's terrible and that we shouldn't use it. But what I am saying is that it can be more cumbersome when adding multiple numbers because you start to count up higher and higher. We are really quick with addition facts for single-digit numbers. We are less quick with addition facts for double-digit numbers or triple-digit numbers. The Scratch algorithm keeps it so that we're only adding single-digit numbers at any time. Whereas the standard algorithm, you might be adding double-digit numbers like 12 and 9 or 16 and 4. Either way, you will get the same answer. It's all about what makes sense and how we can teach differently so that things can make sense to people who think differently.